Okay, before we go on, I want you to make sure that you have a couple things set. Okay, first of all, we need to be sure that the bull nose of that roller is going to be riding on the cam. Okay, so that roller must be riding on the cam. If this is turned 90 degrees, it's not going to work. Second thing I want you to make sure of before you go any further is make sure that your cam is at 0 degrees or 90 degrees, or that revolute. It would be best if it's at 0, but 0 degrees being straight up, and the eccentric cam being at the lowest point. Okay, because you need to understand how this works simply before you get into something more complicated. So if this is 90 degrees, for this to be at the lowest point, that's okay. Okay, it will figure, it'll work out. Okay, and second, then let's pull around and let's look at this and notice if I pull this down, I'm editing that slider joint. Okay, and I'm at negative 2.6 inches. So I know because that this was built in inches, if I go negative 6.25 inches down, that cam is touching the roller perfectly. Okay, because this was built in inches, and so that's now 2 5/8 below the top that I've selected there. That's also why it's a little bit easier to select the top of the roller for that slider joint rather than picking the follower, because then if you decide to modify the length of the follower and shorten this, it's not going to modify the offset of this value. Okay, if you want to modify this length for whatever reason for your automata. Okay, so that's why that's a better choice. Okay, so I've made note that is negative 2.625 inches. Now, depending upon how you modeled this, sometimes that might be, negative 2.5 inches, and then as I move up, the values get smaller for the offset. Okay, sometimes the values get bigger to where the value up here will increase in size. So it just kind of depends on the origin. So what's important, what you are going to set is that Z offset needs to equal that value. And then you're going to set joint limits, either a maximum or a minimum. Okay, so this is negative 2.625. Okay, so I've got, that's that offset. I'm going to right click on that joint and let's edit the joint. Let's see. Let's edit the joint first. So the Z offset, if you look at this up here, and if you remember on mine, I had to flip it. So if you didn't have to flip it, I'm going to have a minimum. If you didn't have to flip it, you might have a maximum. But the Z offset needs to be negative 2.625. Okay, and you can see that moves it down kind of to where it should be. And then actually, because I had moved it physically, it's now in the wrong location. So then I'm going to right click and edit the joint limits, and I want the minimum to be negative 2.625. So you're going to notice that that moves it back up, and I want a resting position of 0. And that didn't move it. So let's see why we have a problem. Oh, there it goes. It just took a minute. I had to kind of jostle it, and it took a minute to snap back in place. Because see, now that I've selected its resting position, okay, let's look at that again for that slider. Edit the joint limits. Okay, that joint limit is either going to be a minimum or a maximum that it has to rest on the cam. A minimum or a maximum. And the rest is needs to be 0. Okay, and So now that that's activated, even if I move this, it snaps back into position when it's at rest. Okay? And again, the slider, if you edit the joint, okay, that value, the offset of Z, which is the up and down, the offset of Z needs to be the same value as your minimum or maximum. And the minimum or the maximum depends upon the way it was assembled and the way it was oriented. So it could be either one. Okay, and then finally, in order to animate this, you go up to Assemble, and you're going to enable all contact. So now if I start enabling contact, we can see if I rotate it manually, it starts rotating around. Okay, and then if I go into my revolution, that's what I want to drive, I can animate the model and it will drive on its own. Okay, this assembly works very well for the eccentric, the pear cam, and the hex cam. The snail cam gets a little tricky. So we'll find out how that works in the future, but there's the basic assembly of an automata. And if you want to animate what's also going on top of your box, you know, there's going to be additional constraints on there if you have slider joints or just pins, or if you're just bouncing things up and down. Okay, so all in all, Fusion assembly much easier than Inventor. However, it's still a work in progress, so Fusion sometimes gets a little janky with the animation.